There's three major scenarios when solving exponential equations, and I'm about to cover those with you today. My name's Miguel, also known as the Vegan Math Guy, and this is SOH CAH TOA Park, where we're going to explore exponentials when the bases can turn into the same value, the bases are different on both ends, and a tricky scenario where there are exponential equations on both sides. If you want to become part of the math community, please feel free to subscribe to this channel or follow me on Instagram and TikTok, where I post daily math content for you to enjoy. And with that, let's grab our math survival kit and get exploring. These are the scenarios where we can convert the bases on one side to match the base on the other. And what I'm looking at in particular is you can notice that I have an 8 and I have a 2 as my bases, and the 8 can turn into a 2. Whoops, I put a highlighter there. That turning into a 2 cubed. And that means my equation could be 2 cubed times x minus 1 equals 2 to the power of x plus 2. And now because these bases are equal to each other, I can go ahead and make the exponents equal to each other, because the idea is that since these two are the same, the bases are the same, so therefore the exponents are going to be the same. And now I have 3 times x minus 1 equals x plus 2. Let's go ahead and distribute the 3 to both parentheses, and I get 3x minus 3 equals x plus 2. I can go ahead and subtract the x to both sides. That gives me 2x minus 3 equals 2. Final step is to add the 3 to both sides. Actually, that is not the final step, second to the last step. 2x is equal to 5, and then I can go ahead and divide both sides by 2 and get x is equal to 5 halves. Okay, let's go ahead and do the problem here on the right, number 6. Again, we have 144 on one side, we have the 12 on the other. Hopefully you can see that the 144 can turn into 12 squared and include the 2x plus 1 as well. And now we have the same scenario. So we can go ahead and take the exponents and just set them equal to each other. Hopefully that's making sense. If not, please feel free to let me know what else I can do to make this a better experience for you. So let's go ahead and distribute the 2 to the other side. 4x plus 2 equals 5x minus 1. Okay. This time, I'm just going to go ahead and subtract the 4x to the other side. Doesn't matter which one you subtract to the other side as long as you have both x's on one side and the constants in the other. So now I have 2 equals x minus 1. And the last step is to go ahead and add the 1 to the other side. And now x is equal to 3. All right, let's go ahead and do the one on the bottom, number 7. We have a 5 on the left, 25 as the base on the bottom. So the left side can stay the same. The right side is going to become 5 squared times x plus 1. And so now I have 5. Actually, I can just go ahead and take the exponents and set them equal to each other. Not sure what I was thinking there. And now I have 3x plus 1 equals, let's go ahead and distribute the 2. So 2x plus 2. And then I'm going to subtract the 2x to the other side. And let's go ahead and create some space here on the right. This is going to become x plus 1 equals 2. Last step is to go ahead and subtract the 1 to the other side. And I get x is equal to 1. Let's go ahead and look at number 8. 4 on the left, 2 on the right as my base. So I can convert the 4 into a 2 squared. And then negative x plus 1 equals 2 to the power of 2x. And now I can set the exponents equal to each other. And let's go ahead and distribute the 2 on the left here to both values in the parentheses. And I get negative 2x plus 2 is equal to 2x. All right, let me go ahead and subtract the 2x to the other side. And be very careful with this because this is going to be tricky. Negative 4x plus 2 equals, some people for whatever reason forget that 2x minus 2x on the right side, that's going to equal to 0. A lot of people get confused because it goes away. And so now, final 2 steps is to subtract the 2 to the other side. Then get negative 4x is equal to negative 2. And let's go ahead and divide both sides by negative 4. And that is x equals 2/4. If I simplify that, that's 1/2. And now let's go ahead and talk about scenario number 2. This is a bit more complicated. And at this point, we're probably going to use our math compass, aka our math calculator. So the very first thing that I want to do is for number 9, I want to make sure that I just isolate the exponent. So I'm going to go ahead and divide both sides by 5. And let's see if I could even do anything about that in terms of changing it into the same base. So I have 18 to the power of 6x is equal to 26/5. That's a tough one, right? There's nothing that I can do to change this so that they have the same base. So what I'm going to have to start doing is the method of taking the natural log. Some people call it taking the ln of both sides. And the reason why I'm doing that is because now I'm going to be able to take this 6x. Looks like I erased it. Let me go back. I can take this 6x and I can apply the property of exponents and bring the 6x out on the outside. So then I have 6x natural log of 18 is equal to natural log of 26/5. Okay. I'm not going to simplify this until the very end, meaning I won't use my calculator until I'm officially done by isolating the value of x. So what I'm going to go ahead and do is I'm going to divide everything by natural log of 18. And that's going to give me 6x equals natural log of 26/5 divided by natural log of 18. And then the final step is to divide everything by 6. And this could become natural log of 26/5 over natural log of 18 times 6. That 6 can go on the bottom there. And this is where I use my math compass to find my value. And I get a value of x equals 0.095. You know, it's all going to depend on how much your teacher wants you to round this to, whether it's like the nearest tenth or the nearest hundredths. Some people want 3 decimal places. So really up to the teacher or really up to you as to how many decimal places you want to round it up to. And that is our value of x. Let's go ahead and do number 10. Again, you want to isolate the exponent. So I'm going to go ahead and bring the 5 to the other side. Add 5, add 5. And I get e to the x minus 1 equals 10. And once again, I need to implement that natural log to both sides. Some people call it the ln. And that will bring my x minus 1 to on the outside. Natural log of e equals natural log of 10. Now, this is a special treat because hopefully we could identify what the natural log of e is going to be. If we don't, that's okay. We just continue to, write everything out. And at the end, you're going to see that natural log of e is equal to 1, which is kind of nice because now we can go ahead and have x minus 1 times 1 is equal to natural log of 10, which is the same thing as x minus 1 is equal to natural log of 10. Let's go ahead and add the 1 to the other side. X is equal to natural log of 10 plus 1. This is actually a really nice answer that we can leave like this, or we can use our math compass and get that x is equal to 3.303. All right, let's go ahead and work on number 11. So I'm going to go ahead and bring the 3 to the other side by subtracting the 3. And that gives me 9 to the power of n plus 10 equals, what is that, 78? And there's nothing I can do. This looks like one of the previous problems that we did in the other slide where we can actually turn the base into something with 9 or maybe 3, but in this case we can't, unfortunately. So it's going to be the same problem when we go ahead and take the ln of both sides. And now this becomes n plus 10, natural log of 9 equals natural log of 78. Let's go ahead and divide natural log of 9 to both sides. And that leaves me with n plus 10 equals natural log of 78 over natural log of 9. And one last step. Let's go ahead and add the 10 to both sides. And that leaves me with n equals natural log of 78 over natural log of 9 plus 10. And at this point, you can go ahead and plug it into your math compass and find the decimal value for this, or you can leave your answer like this. This will actually be the exact answer. The value that you find in your math compass as you round it is going to be the estimate. All right, we have one last problem with number 12. So as I write this, I keep using my highlighter. Sorry about that. 11 and minus 8 minus 5 is equal to 54. Let's go ahead and add the 5 to the other side. That gives me 11 and minus 8 is equal to 59. And again, natural log of both sides. I should have created some space that I can fit on the right side, but that's okay. It happens. So I have n minus 8 natural log of 11 equals natural log of 59. Last few steps, divide both sides by natural log of 11. That leaves me with n minus 8 is equal to natural log of 59 over natural log of 11. And last step, let's go ahead and add the 8 to both sides. And that leaves me with n equals natural log of 59 over natural log of 11 plus 8. And that is my final answer. Awesome. So again, if we cannot turn the bases so that they have the same value, we need to implement this natural log rule so that we can bring the exponent down below and then solve for our variable. Let's go ahead and look at the last few problems. These are the crazy and nasty ones. Bear with me. I know that it's a small image there, but I'm just going to go ahead and write the first one. These are one of the hardest types of exponential equation problems that you might encounter. The reason being is because you have exponents on both sides. And unfortunately, although this looks very similar to the first slide, we can't change the basis so that they're the same. So what we have to do is we have to continue using that natural log and taking the natural log of both sides. And we're going to have to bring the exponents out in the front. So I have x plus 3 natural log of 2 equals 3x minus 1 natural log of 5. This is where things get really tricky because we can't just divide the natural log of 2 to the other side or perhaps the natural log of 5 to the other side. We need to go ahead and distribute both of the natural logs to these values. So I'm going to go ahead and do x natural log of 2 plus 3 natural log of 2 equals 3x natural log of 5 minus natural log of 5. Okay. Hopefully you can see that I have some x values and then I have some constants in the 3 ln of 2 and the minus ln of 5. So that is exactly what I want to combine. So what I'm going to go ahead and do is I'm going to start off by subtracting the x natural log of 2 to the other side. And that's going to give me 3 natural log of 2 equals 3x natural log of 5 minus x. That 5 looked ugly, so I'm just going to change it real quick. There you go. Nope. Let's try one more time. Nice. X natural log of 2, and then I still have that minus natural log of 5. And now let's go ahead and add the natural log of 5 to the other side. And so I have 3 natural log of 2 plus natural log of 5 equals 3x natural log of 5 minus x natural log of 2. So just to make this easy on us, let's go ahead and factor out the x that's on the right side. What I mean by that is this x that they both have in common. And this is how that's going to look like. I'm going to have 3 natural log of 2 plus natural log of 5 equals x on the outside, 3 natural log of 5 minus natural log of 2. So even though it looks pretty ugly, I'm still going to have a value on the right side here that doesn't have a variable. So what I can go ahead and do is I can go ahead and divide both of those values to the other side as a whole. because technically this is just a big number or a decimal that we don't know what it is, but it's guaranteed. I promise you that it is going to be a decimal value. And so now what I have is this big sort of expression on the left side, 3 natural log of 2 plus natural log of 5 over 3 natural log of 5 minus natural log of 2. And that is our answer. You can plug this into your math compass again, but just be very careful that you're using your parentheses correctly, because otherwise the calculator will not register what you're telling it and it will give you the wrong answer. So just as a heads up. All right, let's go ahead and do the last problem. We're going to start it off up here, 2 minus 5x. Okay, so same thing. I need to go ahead and introduce the natural log to both sides. So then I have 3x minus 8 natural log of 10 equals 5 minus x natural log of 2. And now I can go ahead and distribute the natural log of 10 and the natural log of 2 to both values. 3x natural log of 10 minus 8 natural log of 10 equals 5 natural log of 2 minus x natural log of 2. So again, look at that 3x and that x ln of 2. I can combine those. So what I'm going to go ahead and do is I'm going to add x ln of 2 to both sides. And that's going to give me 3x natural log of 10 plus x natural log of 2 minus 8 natural log of 10 equals 5 natural log of 2. And then I can go ahead and add the constant in the 8 natural log of 10 to the other side. And we are almost done. Let me just go ahead and write this down. So I have 5 natural log of 2 plus 8 natural log of 10. And as a final, well, I guess second to the last step, the first thing that I should do is I should factor out an x from both of the values on the left side. So I have x times 3 natural log of 10 plus natural log of 2 equals 5 natural log of 2 plus 8 natural log of 10. And one final step, so we get our answer. 3 natural log of 10 plus natural log of 2 is going to be divided to both sides. And that leaves me with x equals 5 natural log of 2 plus 8 natural log of 10 all over 3 natural log of 10 plus natural log of 2. These are usually extra credit problems, but if you're in honors algebra, honors pre-calc, I wouldn't be surprised if problems like this come up. So be aware of them, know how to solve them, get comfortable with them, and you will find these much, much easier as you continue to practice them. And that's all I have for today, so please feel free to comment below and let me know what you want me to cover. And with that, happy trails.